Well, hi guys, and welcome to a very important lesson today, trying to wrap up everything we've done in the last couple weeks. And the main goal of this whole unit, the polynomial unit, is to be able to graph anything. And to be able to graph anything without a calculator, you need to be able to factor it. And if you can factor it, you can find roots. If you can find roots, you can find behavior at roots. And you can look at end behavior and bring all this together. And so what we're going to learn today is, how do we know what numbers to try to see if they are a root or not? In your homework that you did in class today, you were told what numbers to try. Today we're going to figure out, what if you're not told? What if you're just looking at a polynomial and you're sitting there thinking, what do I do now? There's a whole bunch of numbers to try. What you're going to learn today are just some strategies and some hints on what numbers to try so you can start breaking it down. All right, so we're going to begin with the rational roots theorem. The rational roots theorem, they tell you what are the possible rational zeros. Now, rational numbers are numbers you can write as fractions, so these will not include any square roots, but they will include all of your fraction or integers. And so if you have some polynomial, the two most important things are going to be the coefficient, the leading coefficient, and the constant term. We learned that vocabulary when we first started this. Well, you learned that vocabulary when we first started this if you watched the videos. But anyway, this is our leading coefficient, and then this is our constant term. And these are going to be the only things we need to look at when we're just sitting there scratching our heads and thinking, oh my gosh, what number should I try here? All right, so we're going to look at the leading coefficient, and we're also going to look at the constant term. And the only possible rational roots are all fractions where the factors of the constant term go on top and the factors of the leading coefficient go on bottom. And this is going to be a big list, but even if your list is 30 numbers long, that's still less than infinity. So that, some of you might think, oh, well, this list is too long. I can't guess and check through that. Well, try and guess and check through all the possible numbers. And so this is really going to be a big help for us. So let's take a look at an example. Use the rational zero theorem to list all the possible rational zeros for this function. Now, before this lesson, if I just told you to factor this, you're like, well, what number do I try? How do I know what number to use synthetic division for? There's an infinite possibilities. You are going to list all of the factors of the constant term, including positives and negatives. So every number that goes into 12 is this following list: plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Those are that's a list of all of the numbers that will divide into the constant term, and that's what we're going to call P. Q is all of the numbers that will divide into the leading coefficient. Now, the leading coefficient is -1, and the only numbers that will divide into that are plus and minus 1. So the possible rational roots, or zeros, are all of these numbers of P over all of the numbers for Q. So you're going to write all the possible fractions. So they are plus or minus 1 over 1, which is just 1, plus or minus 2 over 1, which is just 2, plus or minus 3 over 1, plus or minus 4 over 1, plus or minus 6 over 1, and plus or minus 12 over 1. So this gives us 12 possible rational roots. Now again, this does not include square roots, but at least it narrows down the list of all the integers and fractions down to a manageable number. So those are the only ones to try. So it's all the factors of P, which is the constant term, divided by all the factors of Q. Those are the only possible rational roots. On your homework tomorrow, that's the very first thing you're going to do, or the very first part is just list the possible rational roots. Now, we're not going to try them for this example. We're going to try them here in the next one, but for now it's just listing them, and that will be a common question on the test. List all the possible rational roots. Okay, now we're going to list all of them. We're going to use synthetic division to test them, and I'm going to give you some hints on what to try, and then we're going to find a zero. We're going to break it down and find all the zeros. So here is a polynomial, and our goal is to factor it all the way down to find all the roots. And so what we're going to do is start by listing all the possible zeros. So the possible rational roots are going to be, we're going to list all the factors of negative 100 we can think of. Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus, anything bigger than 10. Does it go to 25 here? I think it does, because 10 is the square root. So now we're going to, start heading back the other way. So plus or minus 25, because 25 times 4. I missed the plus or minus 20, because that's 20 times 5. And plus or minus 50 and plus or minus 100. And those are all of the factors of the constant term. And we put these all over the possible factors of the leading coefficient. And that's just 1, so it's all over plus or minus 1. So it's just those numbers right there. Okay, so I'm going to give you some hints. We have 2, 4, 6, 8, 10, 12, 14, 16, 18 numbers to try. Before you start complaining about that, at least understand that that's smaller than infinity, okay? So here are some hints. If the sum of the coefficients is 0, then 1 is a root. Making x minus 1 a factor. So let's take a look. Let's add up our coefficients. We've got a 1, a 4, a negative 25, and a negative 100. So add them up. 1 plus 4 minus 25 minus 100. This does not equal 0. Therefore, 1 is not a root. So we've at least now broken it down some more. So we know not to try 1. Okay. Here's another hint. If we try synthetic division and the numbers underneath the bar are all positive, then we have found what's called an upper bound. In other words, that number is too big. So we're not going to try any numbers above that. So let me show you this. I mean, I realize I just told that to you, but let's try the root 10. Let's try that one. And what I mean is we're going to use synthetic division to see if it's a root. And we learned in class in our video from before, we have to get a remainder of 0 for it to be a root. So let's take a look at this. 1x cubed, 4x squared, negative 25x, negative 100. That goes in descending order. Drop my 1 down, multiply, add, multiply, add, multiply, add. Okay, this did not work. 10 is not a root. But on top of that, all of these numbers underneath the bar are positive. That means that 10 is an upper bound, which means that we should not try anything bigger than 10. Now that's going to help because that's going to take care of the 25, the 20, the 50, and the 100. All right, I'm going to show you another one, and that is called a lower bound. Let's try negative 10. Now, a lower bound is there's no number smaller than this if the numbers alternate. If when you do your synthetic division and they alternate in sign, plus minus, or minus plus minus plus, then we found a lower bound. So take a look at this. We try negative 10 with our synthetic division. Drop that down, negative 10, that's negative 6, 60, that's 35, negative 350, negative 450. Take a look at this. Positive, negative, positive, negative. If that happens, then you have found a lower bound. So that means don't try any number smaller than that. So these are just hints on what to try. So we're even breaking it down further. So now we can go back up and see that we're not going to try any number bigger than 10 or less than negative 10. So we have now narrowed it down to a lot more. We're only going to try the 1s, 2s, 4s, and 5s. And I've already told you before that 1's not a root because you add up the coefficients, it didn't equal 0. So we now have either negative 1, positive 2, negative 2, positive 4, positive 5, or negative 5. That's it. So let's just start trying them. Again, from today's lesson in class, we have to get a 0 as a remainder to get a root. So let's try negative 1. We'll put a negative 1 in the little box. 1, 4, negative 25, negative 100. Drop our 1 down, multiply, add. Multiply, add. Multiply, add. Didn't work. Negative 1 is not a root because that remainder is not 0. All right, well, let's try 2. 1, 4, negative 25, negative 100. Draw a little bar. 2 times 1 is 2. Add. Multiply. What is that? Negative 13? Is that right? Multiply. That didn't work either. All right, let's try negative 2. 1, 4, negative 25, negative 100. Drop that down. Multiply, add, multiply, add, multiply. That didn't work either. All right, well, let's try. Oops, go back a little bit further. Let's try 4. 1, 4, negative 25, negative 100. Multiply, add. Multiply, add. Multiply. That didn't work. Let's try negative 4. Multiply, add. Multiply, add. Multiply. Thank goodness we have finally found one. We found a root because the remainder was 0, which means that we can now factor this down further. My x cubed plus 4x squared minus 25x minus 100 can finally be broken down into the following. Since negative 4 was a root, x plus 4 was a factor. And then what we have left over is x squared minus 25. Which means that we can now look at what we have left over and see if we can factor that some more. And we've got x plus 4 times x plus 5 times x minus 5. So I have factored all the way down into linear factors. This x cubed has 1, 2, 3 factors, which means it has 3 roots, negative 4, negative 5, and 5. Let's see if we answered our question up here. Oh, whoa, 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 cancel. Don't leave me. All right. All right, let's see if we go all the way up here. Practiced a bunch of synthetic division, and I did that on purpose. Okay, we listed all the possible zeros right there, boom. We used synthetic division to test them. We found an actual 0, and we used that to find all the zeros. And on top of that, we learned some other things. Those were, if you add up all the coefficients and you get 0, then 1 is a root. But if you don't get 0, 1 is not a root. And we're trying to narrow our list down. Also, if you try synthetic division and everything underneath the bar is positive, don't try any numbers bigger than that. You have found an upper bound. Also, if you try synthetic division and the numbers underneath the bar alternate in sign, you have found a lower bound. Don't try numbers smaller than that. And then from there, you've broken the list down, and you're just going to have to try some and until you get one that works. And finally we did. Once we found one that worked, we got to bust the polynomial up into pieces, and then we could factor it some more. Alright, so let's do that again. This time with an x to the fourth. List all the possible zeros. So we're going to have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 16, all divided by plus or minus 1. These are the possible rational roots. Okay, so then now we have to go further. Can we find one? Let's try that trick I told you about 1. Let's add up all the coefficients. Let's add the coefficients and see if it's 0, because if we add the coefficients and we get an answer of 0, we know we have found 1 as a root. So 1 minus 5 plus 20 minus 16. Let's see what that is. 1 minus 5 is negative 4. Negative 4 plus 20 is 16. 16 minus 16 is 0. This means that 1 is a root. This graph touches at x equals 1, which means we have found one already to break this quartic into pieces. Quartic because it's an x to the fourth. So since we know 1 has to work, that means we better get 0 as our remainder. So let's do our synthetic division. 1x to the fourth, negative 5x cubed. We need a 0 for our x squares. Notice this did not go in order, so we've got to put a 0 here. And then a 20 for our x, and then a negative 16. Alright, so we'll drop our 1 down, multiply, add. Multiply, add. Multiply, add. Multiply, add. This is really, really nice. So I have taken this x to the fourth, and I now know it factors into x minus 1 times, we took an x to the fourth divided by an x, so we have an x cubed left over. So we have a 1x cubed, these are all the coefficients, minus 4x squared minus 4x plus 16. Now, we are still only going to try these roots right here. We're not going to try any more than these, and we've already found one, and that is 1. Okay, so here we go. Let's try some more. Go up just a little bit. But now, whenever we're going to factor and try, we can try them on the remaining cubic. We don't have to try them on our quartic, so we're breaking this down into pieces. Remember when you're doing a factor tree and you did something like 24 is 2 times 12, once you find a factor, you don't continue and try and factor 24, you try and factor the leftover. What's left over there. So I'm going to try and factor this x cubed now. Still only using these possible zeros. So let's just try one. Let's try 2. So 1x cubed, negative 4x squared, negative 4x and 16. Drop the 1 down. 2 times 1 is 2, negative 2, negative 4, negative 8, negative 16. Boom. We found another one. So now we know this is factored into x minus 1 times x minus 2 times x squared minus 2x minus 8. And I am golden whenever I get into a quadratic. Once I get down to a quadratic that's left over, I can just try and factor that, or I can try and use the quadratic formula. This one factors fairly easy though, because the factors of negative 8 that add to negative 2 are x minus 4 and x plus 2. So all our roots are x equals 1, x equals 2, x equals 4, and x equals negative 2. Okay, now I'm going to do one more, and that's just listing the possible rational roots when the leading coefficient happens to be something other than 1. And we're going to also learn Descartes' rule of signs. Descartes' rule of signs is another hint that lets you know how many positive zeros you have and how many negative zeros you have, so that if you find enough positive ones, then you don't have to go any further. And this has to do with the number of sign changes in successive terms. It also has to do with the number of sign changes in successive terms of f of negative x. So this can help us narrow things down. So let's take a look at that. Here I'm just going to list these terms as 3 a little bit bigger. 3x to the 4th minus 5x cubed plus 2x squared minus x plus 10. So first of all, let's see how many sign changes we have. We go positive, negative, positive, negative, positive. So here's 1 sign change, 2 sign changes, 3 sign changes, 4 sign changes. So there are 4, 2, or 0 positive roots. I want to go back to the other page and I want to tell you why I said 4, 2, or 0. It says or less than that number by an even number until 1 or 0 is reached. So once you figure out the number of sign changes, you need to subtract 2 off until you get to 0. So what this means is this graph either has 4 positives, 2 positives, or no positives. Now the next thing we need to do is look at f of negative x. And that means replace all your x's with negative x. And then we'll clean it up. Okay, so let's see here. Negative x to the 4th. Well, a negative to the 4th power makes it positive. A negative to the 3rd power makes that negative, so that turns this into 5x to the 3rd. And then plus 2x squared, and then plus x, and then plus 10. So once you've found f of negative x, let's look at our sign changes. Positive, 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 positive. F of negative x has no sign changes in it at all. That means there are 0 negative roots. That's going to be very helpful. In other words, you should not be trying any negative numbers with synthetic division because they won't work. Alright, so the last thing I want to do is simply do one where there's a leading coefficient of something other than 1, and I want to list the possible rationals, and then we'll be done. And then tomorrow's a big day. We'll see if you can do this. Possible rational roots. Remember, it's all p divided by q, where p is the factors of negative 18, q are the factors of 5. So, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. Those are the factors of the constant term. That's also called the y-intercept. All divided by the factors of 5. Okay, so this is going to be a long list. So first of all, let's do all of these numbers over the 1. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. But we also need to list all of those numbers over the 5. So plus or minus 1/5, plus or minus 2/5, plus or minus 3/5, plus or minus 6/5, plus or minus 9/5, and plus or minus 18/5. This bad boy has a lot of possible rational roots. So I just wanted you to see that. I will see you guys tomorrow.